Hey everyone. So I wanted to look at this sample that landed on my desk just recently. This happens to be a zloader malicious spreadsheet. And lately I've been doing a good bit of analysis with malicious Office documents. And what I've certainly noticed is an uptick in usage of Excel 4 macros. Now, if you're not familiar with Excel 4 macros, I'll provide a list of references and tweet that out a little bit later after this recording is done. But there's some great references out there. And the difference between a traditional like VBA macro and an Excel 4 macro is that an Excel 4 macro is not written in VBA, or Visual Basic for Applications. Rather, what it allows you to do is... Oh, sorry about that. One sec. Oh boy. Okay. All right. Audio issue fixed there. Cool. Now, what Excel 4 allows you to do is embed Excel commands within an Excel sheet. Okay. And each Excel 4 command is represented in the form of a formula. So a cell will start with an equals character followed by an Excel 4 macro command, and you can pepper these throughout a sheet. So what happens to be populated in this spreadsheet is there's actually malicious code in here. It's not extremely straightforward as to how you would find it, but that's why I'm here today, to help you uncover exactly what's going on here. So normally, if you were expecting this to be a VBA macro, you might go to View, Macros, or enable the Developer tab and look to see if there are any VBA macros. That is not the case with this malicious spreadsheet here. So how do we get started? Me being such a fan of PowerShell, thought that I might try to work with this programmatically using a simple PowerShell script and interfacing with the document dynamically using the Excel com class. All right, so what I'm going to do is I'm going to supply the path to this malicious document. And again, in the document that I'll tweet out later, I'll supply the hash and the link to VirusTotal for the sample if you'd like to play along. So we're going to start up Excel using the com class. So the way you do that in PowerShell is you just call new object dash com object and then supply the com prog ID, in this case excel.application. Next, you're going to open up the Excel workbook using the specified path. Now let's go ahead and do that. Okay. Now this workbook object that's returned has a ton of implemented properties and methods. So if I pipe that to getMember or GM, the alias for that, you'll see a lot of stuff here. Okay. My understanding is, well, yeah, I don't quite recall. I believe you would go through the VB project property of this workspace to go and inspect programmatically if there was a VBA macro associated with this. Because we're dealing with an Excel 4 macro, turns out what we're going to be looking at here is the Excel 4 macro sheets property. So when you define an Excel 4 macro, you have to have a sheet that is dedicated to Excel 4 macros. All right, so let's check that out. And if there's at least one object returned, then that's an indication that there's at least one Excel for macro sheet enabled. So there's one here. It's named Sheet 2. I'm not seeing any others. Yeah, so there's just that one. So Sheet 2, which corresponds with this sheet right here, okay, which appears like visually to not have anything in it, right? But we're going to confirm whether or not that is indeed the case. Now, what I've heard some malware authors like to do is to hide their sheets. So in the UI, the way you do that is, well, if this Excel was actually licensed, then I could just click hide and hide that sheet. Within COM or PowerShell, I can just set the visible property accordingly. I forget the exact value that you would set to hide it, but just know that that's a thing, that these sheets can be hidden. So what I'm going to do is I'm just going to go back to my script, and the way that you pull items out of Office documents using COM is, even though this can return an array of objects, because it's COM, you have to extract it. You have to extract these objects out individually using the item method. So I'm saying, give me the item, in this case a sheet named Sheet 2, and now I have this specific sheet to work with. And as you can see, there's quite a few properties associated with that. All right, so the next question is, how would we go about identifying if there are any populated cells in this spreadsheet? So after Googling around, not really finding a whole lot of useful information, I was able to find a little bit. So what we're going to do is we're going to go through every single cell within the sheet and see if there's a populated cell, right? So one way in which you could do that would be via the cells property. So if I just ran count on that, you would see there's quite a few cells. One thing that you can do to attempt to whittle down that number of cells is to use this call to special cells. So 11 corresponds to the last populated cell. That's my understanding. So if I copied this out, then we check that out. I'm looking at the formula property to see if there's any actual value here, or the value property to see if there's a defined value, which I'm not seeing. So what I'm going to do next is I'm going to work with a range of cells. And so I'm going to say, hey, Excel, give me the range of cells starting from cell 11 or A1 to the last defined cell in this sheet. Okay, so that actually gives me the same count as before. So I guess this little trick didn't really bias anything, calling the special cells method here. But what you will need to do is still get get this range object returned, because from this range object we're going to be able to call a find method. And so what we're going to do next is we're going to search through every cell, and any cell that is a formula, in other words starts with equals, I would like to get those cells returned to me. And I'm going to save those to this cell array. Okay. So the way this works is, upon calling find from this range object, it will return a single cell if it finds a cell that matches the search criteria. All right, so I'll save that cell here. Here we can inspect that single cell. Okay, so what you see here is text. So this is the, here's the actual value of the formula. Now another reference that I'll link to later is a massive like Excel 4 macro reference, which documents all of these macro commands. So set.value, my understanding is it just takes the second argument, the contents of the second argument, and then sets it to a cell. In this case, the FW 4150 cell. So there's a question, can't formulas start with plus and the @ sign as well? My understanding of Excel 4 macros is that they need to start with equals. I'm not an expert here, but that's just been my observation. Okay, so the next thing that we're going to do is we're going to save the row and the column of the first populated formula cell. And the reason that we need to do that is because if you call find, and let's say it only finds a single cell that matches your search criteria, it's just going to loop indefinitely, coming back to the same cell over and over again. So what we're going to do in our looping logic is for every cell that we find, we're going to add it to the array. And then we're going to call find to find the next cell. And we're going to break out of the loop when the cell returned matches the first row and the first column of the first populated cell here. So that's how we'll break out of that. So let's run that. Okay. All right, so populated cell. Let's see how many of these things were returned. Oh no, sorry. Cell array is what I'm interested in. Okay, so we got 132 populated cells across like 16 million possible cells. So why don't we check out the contents? Just kind of poke around a little bit here. Why don't I take the contents of the formulas and pipe it to sort unique. Cool. And now I'm just gonna save this out to a text file. Okay, so let's try to make some sense out of this here. So I see a bunch of calls to formula fill, a bunch of go-to statements, run statements, and set value statements. So if you've worked with obfuscated code previously, then this should start painting a picture for you. So even without really knowing how these Excel 4 macro commands work, we could probably wager a guess as to like what's going on here, right? So formula fill, so maybe fill the contents of a cell to something, right? So we have all these character commands which appear to do various kinds of math, right? So take the contents of this cell plus the contents of this cell and cast it as a character, right? And then concatenate it to the result of this character that's calculated. And then over here at the very end, the resulting concatenated or deobfuscated string is then saved to this particular cell. Okay. Next we have a bunch of go-to statements. Now, the way Excel 4 macros work is there's a special cell that you would name called auto_open if you wanted to like auto execute your cell upon opening the spreadsheet. And then so it would run that cell, and then every cell that is beneath it would execute in sequence. So what go-to statements facilitate is control flow obfuscation. So this is what would allow in an obfuscated document to have the logic of the macro sort of like peppered all over the contents of the sheet. Next, we have a run command, which you could think of this like an eval command. So this is going to run the contents of a macro that is stored within a specific cell. Right? So this should kind of make sense, because if we're having all of this stuff, all of this executable code presumably deobfuscated on the fly, then the way you would go about executing that in a dynamic fashion would be to call run on it. And then we have some additional obfuscation going on here where the contents of cells are populated dynamically based on the retrieval of one cell's contents and then doing some math on it. So this is your pretty typical obfuscation techniques going on here, just implemented as Excel for macro logic. Okay, so what do we do next? What we'll want to do next is identify the name of the auto open cell. So this is going to be the cell that executes upon loading the spreadsheet. Now, typically, what you're supposed to call the cell is just auto open. And then Excel will know to just automatically execute that starting at that cell. Apparently there's a trick where you can get away with appending like garbage to the end of auto open, and Excel will still auto run it. But what happens is when you go to search, or no, with Control G. Oh, I don't know if I can do that yet. Well, let's see. Let me go to the cell. So what's the cell? Row, column. Okay, so we got 27084. I think there are some features disabled here since I didn't go through the steps to license this copy of Excel. 27084. And row 79. Okay, there it is, right here. So this is the first thing that will actually execute. Boo. Let's see. So I don't know if it will actually let me run this. But what I'm going to do is I'm going to you know what? I'm going to see about getting this copy licensed, and I will be right back. So give me just a couple minutes, and I'll try to get this figured out, because I'm gonna need to like edit this on the fly, and I can't do this until I license this. So I will get that taken care of, and I will be right back. Okay, and we're back. Sorry about that. Now this shows that it's still unlicensed. Let me try this one more time. Okay, cool. Looks like we're good. Okay, so let's grab this name and do Control G. There we go. Now we can do it. Normally, if it was just a normally named auto_open cell name, you would see it here, is my understanding. But because of that odd naming scheme that's used, you're not going to see it there. So, but because we programmatically extracted that, we can just paste it in there and jump right to it. All right, so what I'd like to do with this analysis is step through everything, like step through every command individually to understand like what control flow is going on. But what I don't want to do is have it run away with execution without me under control of that execution. So one way that I can do that is, like, if I just let this macro run, it's gonna execute this cell and then execute the next cell, jump to there, and then jump all over the place based on the obfuscated control flow. So I don't want that to happen. So what I'm gonna do is I'm gonna do Control X and just paste that go-to statement up here. Now, I'm going to hit enable content, and the only cell that's going to execute is just this cell value, or the set value cell. Okay, so let's get that going. All right, so I just enabled that, so it should have executed. So now what I can do is click on this go-to, and I'm going to right click and go to run. Okay, so and now from this dialog, I'm going to click step into. Now I need to be careful here. I don't want to click run because then that's just going to continue execution and not allow me to control the control flow. The main buttons that I'm going to be pressing here is step into and evaluate. So step into like is going to execute things one by one. Evaluate is going to show me the execution of a single command at a time. So for example, those formula fill commands, as they deobfuscate the string, like character by character, you can use evaluate to see that being dynamically deobfuscated, which is pretty cool. Okay, so I'm just clicking through execution and we've landed at the set value. All right, I'm just going to keep clicking through until we get to some more interesting code here. Okay, so here's the first instance of string deobfuscation, it would seem. So I want to see this deobfuscate in real time, so I'm going to click through and do evaluate. And so you can see this character, or the string populating. Okay, so close false. I looked this up, and what this does, my understanding is it will close the workbook that you're working in. And so that's something that we would want to be mindful to avoid. And you're going to see this come up quite a few times. All right, so take note of that. So it's going to save the contents of that macro command, close false, to cell BR26512. All right, here, let me take some notes while we're at this. Okay, so is going to be at BR26512. All right. So I'm going to evaluate that, and we're just going to keep running through execution here. So we have some more strings being deobfuscated. Okay, at maximize. I'm not really going to read into why that's implemented. Okay, so here's an if statement. If get Windows 7, go to what? Go to BR26512. So my feeling is that this is some kind of anti-analysis trick going on. Because thus far, like, really nothing interesting has happened, right? But if this returns true, then it's going to go to that close command, and it's not going to do anything interesting, right? So what I'm going to do here is I'm going to go to this command in the spreadsheet, just jump to it. And instead of letting this if statement evaluate, I'm just going to jump to the next command, right? Because again, I want to avoid jumping to BR26512 because that's just going to close my worksheet and not execute anything further. All right. So I'm clicking on the cell. I'm going to right click, go to run, and step into execution again. All right. So we are proceeding. Okay, here's another get window. Let me just complete the evaluation of that. Okay, so if that, then go to the same close statement. So again, I'm going to go to go to, and I'm going to jump over execution of this, just not even let it run, and dive right into the next command. All right, here's another if statement, get window something or other. Okay, another what seems to be an anti-analysis trick. So I'm going to jump over execution of that and jump into that go to statement, step into that. Okay, now instead of a get window, we have a get workspace that also jumps to that close command. More, again, this appears to be more anti-analysis tricks. So, by the way, when I click step into, I'm just having this, all of the execution evaluate, and just, I'm going to step into it. So I don't have to like click a million times to have the whole string deobfuscate. Okay, here's another anti-analysis trick. So I'm going to jump to that, not let it execute, and jump over it. Okay. Bunch of these if statements going on. Okay, I want to jump over that. And step into, what do we got going on here? Yet another if statement. I promise these won't last too long. We'll get into the interesting meat of this payload in just a moment. Okay, so we got to jump over that. Yep, run, step into. And I think we're starting to wind down in these anti-analysis tricks. So I'm going to jump over this one. So this one's a little bit different looking. If is number search Windows get workspace 1. Interesting. I don't really quite know how to read into that, but I'm also not terribly concerned about it because the branch of that, if it returns true, is to close the worksheet, which means I want to jump over that. Okay. What do we got now? Hey, thanks, Windows Defender. All right. So this is the first kind of interesting piece of functionality here. All right, so this resolves to export the current Hive software in Microsoft Office. So something is going to be going on related to the registry. So let's step into that, run that. And then, okay, C users public random string.reg. Okay, so looks like we're going to have registry key settings saved to this file, this reg file. All right, what's next? All right, get workspace. Oh, okay, Excel security. So perhaps export the Excel security registry keys. And then call what? C Windows System32 reg.exe. Okay, yep, that makes sense. And this is what I think is crazy about Excel 4. Now, I know you can do this in VBA macros, but just the fact that you can define and then call Win32 like DLL export function, I think is pretty crazy. So shell execute A within the shell32, shell32.dll is going to be called here using the open verb, presumably to invoke reg.exe. All right, we'll let that continue. And I just saw a box pop up, so I presume reg.exe just executed. Okay, so while is error files, blah. My guess here is that like there's going to be a loop that executes waiting for the .reg file to complete writing. Okay, yeah, here's a wait. We'll just let that run. Next, I don't know. I don't really know what that means, whatever. Okay, fopen, so this opens the contents of a file. What do we got here? Fpause, so that sets the position within the file in preparation for a file read or a file write. Okay, so we have an fread or a file read. So presumably we're going to read the contents of that .reg file that was written to disk by reg.exe. Close the file, most likely. Okay. Okay, delete the .reg file, which seems reasonable considering we've already read the contents of it into the contents of a cell. All right, so if is number search 0001, interesting. Then what? Here, let me just step into that. Okay. So I assume this is looking for 0001 within the contents of the .reg file. I didn't think ahead to look at the contents of that reg file to really fully contextualize what 0001 means. But you see the branch target, right? That BR cell. This is going to jump to the close command, which is what we'd like to avoid. So kind of an interesting anti-analysis trick based on what appears to be searching for a specific Excel security value being set in the registry. But we're going to move on and jump over that and not let the if instruction run. All right, so we're going to proceed. Okay, so C users public, looks like another file that's going to be dropped to C users public. So interesting indicator there. HTML file. Interesting. All right. Ooh, we got a URI here. Huh, docs.microsoft.com. Not clear on how this could be used as like a possible C2. I know that you can write comments within the Microsoft documentation. I think you have to be like logged in to do that. So if I was to throw out a conspiracy theory of that being used as C2, you know, I'd want to follow up on that. But I would take note of that and investigate. But we're gonna proceed here. Okay, and then a call to urlmon.dll. The export function is URL download to file A. Okay. So it looks like the contents of that Microsoft documentation is going to be saved to that HTML file that was specified in C users public. And what's next? So files. What do we got? An if. Oh, this appears to be that like looping. Oh, that looping logic. Okay, so I think it's looking for to see if the contents of that file is actually populated with something. So scratch my conspiracy theory about Microsoft documentation being used for C2. What I believe this is doing is it's just like an internet connectivity anti-analysis check. And so by reaching out to an otherwise benign URI, you might not be tripping any security products. And so if you're in a VM like I am that's not connected to the internet, then I guess malware author would consider this to be a reasonable check to just close this spreadsheet out, because what good is this macro going to be anyway if this happens to be like a downloader, right? So what we want to do here is click on go to and jump over that logic, because we don't want to close out the contents of this worksheet, or workbook, I mean. Okay, so let's proceed. Okay. All right, we got another C users public and another HTML file. Okay, interesting. I wonder how that will be populated. Ah, this looks shady to me. Shady indeed. All right, so I assume at this point that this macro will reach out to this potential C2 domain and save the contents of what's returned to that HTML file in C users public. Okay, yeah, I expect this to be, yep, URL download to file. If is error. Okay, what's going to happen here? Is this going to close the worksheet if it fails to run? No? Okay. Have we gotten past all the anti-analysis checks, perhaps? That would be great. Interesting. Oh, what's this? Could this be like a backup C2 maybe? Interesting. Because another HTML file in C-users public was not specified, right? So maybe upon failing to reach out to the first C2, this could be like a backup. Yep, followed by another call to URL, download the file, followed by, oh, what's this? That's interesting. This workbook cannot be opened or repaired by interesting. So looks like the attacker is kind of lazy, and I assume like this would be like an alert box that would pop up, and instead of showing like a decoy spreadsheet, again, like the malware author being lazy is probably just going to throw up their hands and say, oh, your spreadsheet is corrupted, so just move on, nothing to see here. Hey, there's that alert. Okay. Oh, see Windows System 32 run DLL. Interesting. Interesting. Run DLL 32. So what would presumably be executing? Because the only thing that is downloaded thus far is that HTML file. DLL register server. So is run DLL 32 going to call DLL register server on that HTML file? I happen to know that that's possible. Like if you run a DLL through run DLL 32, that DLL doesn't have to have a DLL file extension. Okay, and we're calling shell 32, shell execute a, okay. Oh, URL, download a file? Oh, is it gonna try to like download that again from the backup C2 perhaps? I don't know. Okay, here's something I'm gonna want to investigate. So this branches to someplace different, not that like BR cell that actually closes the workbook, but I'm gonna save my place here so I can come back to this, because I want to go to here and see where this actually might take us. Oh, that alert. Okay, which would say like this this spreadsheet is corrupted or whatever. Okay, so I think I want to jump over that and dive into this go-to statement. Okay, so step into that. Okay, there's that C2. Download the file. Alert. Okay, so let's step into that. Okay, there's our message box, but we're still continuing our execution here. Oh, there's run DLL 32. Calling DLL register server. Okay, run DLL 32 at this point is going to be executed. Ah, there we go. Okay, so run DLL is saying this file doesn't exist. So yeah, my theory appears to be true that upon downloading yojw.html from one of those C2 servers, it's not an actual HTML, or it shouldn't be an actual HTML file. It should be a DLL. Okay, close. Oh, okay. So I believe this is the end of execution. So let's go to that there. So we just landed here after calling run DLL32. Like there was no like if statement that took us here. So this looks like it's the final instruction. So what I'd like to do at this point is I want to save a copy of this, because with all of this like dynamic deobfuscation occurring, all of the deobfuscated commands are going to be saved in the contents of cells. So as I've arrived to the last instruction, why don't I save this out and then use my little PowerShell script to pull out the deobfuscated formulas. So I'll do that now. I never closed Excel from before, so I'll go ahead and do that. And I rename this to executed. So let me load that up. Pull out all the cells that start with equals or have formulas in them. Oops. Yep. Formula. Okay. Formula. And then let's just write all this to a file. So call this Excel for deobfuscated.txt. Actually, so it's a little bit cleaner. Let me sort the output. And now let's check this out. Hey, look at all that deobfuscated stuff. That is super cool. So just yeah, I'm gonna clean things up a little bit. Because I sorted this, I can just easily remove all of the obfuscated code. And that's all there is to it. Well, that's all there is to the to this macro, right? So obviously this doesn't follow the exact flow of execution due to all those go-to statements that just you know, jump all over the place. But based on our manual analysis and then saving it out, you can definitely start to make sense of what's going on in this and pull out some useful indicators, right? So they're saving the contents of the Excel security settings to users public random file name.reg, saving the contents of a DLL to seemingly random thing.html, and then calling run DLL32 on it, executing the DLL register server export function. This, I at this point assume was just an internet connectivity, like anti-analysis check. And then this appears to be like the primary C2 server, followed by like a secondary backup C2 server. All right. Shell execute A is called twice, once to call reg.exe, and then next to call run DLL32, which will spawn as child processes from excel.exe. So that could certainly be considered suspicious. And we have a whole host of anti-analysis checks. So if you just searched for BR26512, again, that was the one that calls close false on the workbook. Those will correspond to all of the anti-analysis checks, including these here. All right. So that's all there is to this sample. It's just a downloader. So it downloads the DLL and calls run DLL32 on it. So again, just to wrap things up, I'm going to stop the recording here in a little bit, upload it to YouTube, and supply some of my analysis notes in a GitHub gist, and I'll tweet all this out. Before I take off, are there any questions from anyone in chat? And those of you in chat, thanks for joining. All right, I see no questions, so I'm going to log off for now. Again, thanks everyone for your time. I'll get everything posted up here shortly. Take care.